Welcome to this lesson on coordinates and basic straight lines. Today we'll be looking through the basics of coordinates, how we can find the midpoints of coordinates, and how we can sketch or draw basic x equals and y equals straight lines. So we'll start off by looking at a 4-quadrant coordinate grid where we have a y and an x-axis. So the reason that we use a 4-quadrant x and y axes is because that allows us to have negative values for both x and negative values for y. So instead of just having a basic x and y axis like this, we can open it up to give us negative values for both the x and the y axis. We'll start by looking at what is a coordinate. Well, a coordinate is a position on a 2D axis like this, given by an x and a y coordinate. Okay, and I'm sure you've seen this before. It would be given by an x and a y coordinate, and it's always written in a bracket with a comma in between. And it is very, very important that you know that the first part of a coordinate, it represents the x axis, so that represents this axis here, and the second part of the coordinate represents the y-axis, which is the vertical axis. Okay. A lot of students remember this by the expression along the corridor and up the stairs. So whenever you're trying to get to a point on the grid, so if we're looking at this point here, you go along the corridor first, so you go along 3, and then you go up 2. So the coordinate for that point there would be 3, 2, because we've gone always starting from the origin, the center, which is 0, 0. We have to go, to get to here, we have to go across 3, so x would be 3, and then up 2, so y would be 2. Okay, and I'm sure that you've plotted coordinates in the past, but we're just going to review that. And we're going to look at these examples. So example 1 says, plot the point, so the coordinate 1, 1, and label it A. So it's really important that when you read the question, if it asks you to label a coordinate, or put a cross, or put a letter, you do that, because that would be worth marks. So if we want to plot the point 1, 1, well, remember, that means that we would be going x, 1, and y, 1. So that means if we start at the center, always start at the center, we're going to go across 1, and I'm going to go up 1, so that point would be there. So if I mark on that point, and it wants me to call it A. So the point 1, 1 is there. Cross 1, up 1. Example 2 is asking us to plot -3, -3, and label it B. So remember, the first number represents the x, and the second number represents the y. So if we look at our axes, we can start at the origin, always. If we start at the center, we're going to go across -3 to here, and I'm going to go down -3 to here. Okay, so -3, -3 is this point here, and we have to label that B. Okay, you can use a cross, you don't have to use a point, you can put a cross. So we could replace these dots for crosses. A dot or a cross is the same thing, as long as you are showing where that coordinate should be, it's absolutely fine. So that would be point B. And as you can see, point A, we would say, is in the positive quadrant. Both the x and the y are positive. 1, 1, it is both positive, so it would be in the top right quadrant. That is where both of the coordinates would be positive. This bottom left coordinate, B, you can see is in the bottom left quadrant, where both of the x and the y are negative. So if you ever have both coordinates being negative, both x and y being negative, it will always end up in this quadrant here, bottom left. And if you were to think about this quadrant here, what represents that quadrant? Well, that is when x is positive, so when you've got a positive x, and when y is negative, so a negative y, so a coordinate with a positive x and a negative y. So this quadrant here is when x is positive and y is negative. And if we just focus on the top left, just for completion, if you think about what would make a point end up here, it would be when x is negative and y is positive. So whenever you have a negative x and a positive y, the coordinate will always end up in this quadrant here. So that's how the axes work in terms of the quadrants. If we look at example 3, we've got a positive x, 1, and a negative y, minus 3. So if we wanted to plot that point and label it C, we can start at the origin. We always go x first. We're going to go to 1 first, which is here, across 1, and then down 3. So across 1, down 3 would end up here. And our point would end up in the bottom right quadrant, and we'd label that C. So a very good question asked in the comments is, what would 0, 3, what quadrant would that be represented in? That was a really, really good question. Well, that coordinate would be represented in the quadrant 0, 3. If I start at 0 and I go across 0 and up 3, it actually isn't in a quadrant. What you'll see is that point there, if I put that in green, and we'll call that point D, the point 0, 3 actually lies on the y-axis. So it is a point on the y-axis. Just there on where I've marked D. It doesn't actually fall in a quadrant. It actually lies on the axis. So what we could say there, that's an excellent question. What we could say there is, whenever x is 0, so if we pick another point where x is 0, if we have the coordinate 0, minus 2, where again x is 0, if I start at the centre, as always, and go across 0, that means I don't move, and then go to y at minus 2, so that means I go down to y, I would end up there. And again, as you can see, whenever x is 0, you end up staying on the y-axis. Your coordinate will end up on this y-axis. Okay. Similarly, if you think about, going off on a bit of a tangent, if you think about the coordinate 2, 0, where now the 0 is gone to where the y coordinate is, we can see that if I start at the centre and go along 2 and up 0, that means I stay exactly on the x-axis. So if I just change that green to a different colour, we can see that that point would be there. Okay, so whenever y is 0, it means that I'm going to always end up on the x-axis. So this blue coordinate here, 2, 0, I'll always end up on the x-axis because the y is 0, which means I go across and then I don't move up or down. I stay at 0. That was a fantastic question. Thank you for that. So I'm just going to rub out those extra coordinates that I put in, just so we don't get confused with the next part of the examples. Thank you for that question. Example 4 is asking us to find the midpoint of AB. Well, what does that mean? What does the midpoint of AB mean? Well, the midpoint is just a word to represent the middle of AB. Well, that means that we need to connect point A and point B with a straight line. Okay, so we need to connect the points A and B with a line. So if we look at our coordinates A, B and C that we've plotted, AB would be from A to B. So we need to connect that with a nice straight line. So if I connect this with a straight line, and you should use a ruler, luckily mine can just make a straight line for me, I have now got to find where is the middle of this line. So if I'm focusing on this line, where is the center of it? Well, there's a couple ways that you can do this. You can think about just looking at it and trying to find it, like is it there, is it there, is it there? Or you could actually use a little bit of logic and a little bit of maths to work it out. If you think in the x plane, to get from A to B, you go across 1, 2, 3, 4. So if you're going across 4 to get from A to B, half of 4 would be 2. So that means the x coordinate would be in this line here. Somewhere along here the x coordinate would be. And if you think about the y plane, the y-axis, how do you get from A down to B, which is here? It is across 1, or down 2, 3, 4. So again, half of 4 is 2, so the 2 would be there. So what you'll find is the midpoint would meet here. So our midpoint is in fact that coordinate there. Okay, so our midpoint is that coordinate there, and we'll call that MP. MP for midpoint. Now I don't want to write midpoint, I can just write MP. Now if I want to know what that coordinate is, well, starting at the center, how do I get there? How do I get to the midpoint that we've just worked out? Well, remember, you've always got to go x first, so either left or right first. So we're going to have to go left, so to -1 first, and then down to -1. So the coordinate of the midpoint of A and B would be, our answer to this would be -1, -1. Because, again, to get to the midpoint that we've established, you go across 1, down 1. Okay, -1, -1. Now, we will look at how do you find the midpoint if you don't have a grid. Sometimes you don't have a graph to use, and the lines aren't very nicely drawn, and the axes and the grid behind isn't very accurate. So you're going to need a way to find the midpoint without doing it visually, and we'll look at that in further examples. So example 5, it says, find the area of ABC. Find the area of ABC. Well, area, we know, means the space inside. So usually we've got a formula depending on the shape. And ABC, what does ABC mean? Well, if I look at my graph, ABC, if I start at A and go to B and go to C, what I'm creating is a triangle. So that is notation for a triangle. So if I connect all of these lines up, they want us to find the area of this ABC shape, which we can see clearly is a triangle. We need to find the area of this triangle. So, how do we find the area of a triangle? We should know that the area of a triangle is equal to the base times the height divided by 2. The base times the height divided by 2. So we need to use our graph and our coordinates to work out how long is the base and how long is the height of this triangle. Well, the base of this triangle is here. And that is going from -3 to 1. How many units is that across? You can either find the difference between -3 and 1, or you can count. We've got 1, 2, 3, 4 units. Okay, 1, 2, 3, 4 units. So the base of our triangle is 4. Let's check how high it is. Again, you can either find a difference from 1 and -3, or you can just count how many units given our grid. This grid, every square is worth 1, so it's 1, 2, 3, 4. It is 4 high. So we can say that it is base, which is 4, times height, which is 4, divided by 2. Okay, so that would be 4 times 4 is 16. 16 divided by 2 is 8. So the area, now we can't just say 8. When we talk about area, we need centimetres squared, millimetres squared, metres squared. Well, what is a coordinate? A coordinate doesn't have centimetres or millimetres. It doesn't tell us. This doesn't tell us what this grid represents. So if you don't know what the grid represents, you can simply say this is 8 units squared. Because we don't know what the unit of our graph is, we weren't told if it was centimetres, millimetres, metres, we can simply say that it is 8 units squared. When we talk about area, we always have to have a unit squared. And if you do not know what the unit is, you can simply put units squared. Okay, so that would be the answer to that one. And that is very, very common with questions to do with coordinates. They don't just tell you to plot coordinates, they tell you to plot them and then work out the area of that shape or make a shape with the coordinates, or even find the midpoint like example 4. Okay, so that will take us on to example 6, where I discussed a few moments ago, how would we find the midpoint of two coordinates if we didn't have a graph? Okay, so if we couldn't actually look at a line and try and work out the midpoint, how can we do it just by having the coordinates? So we'll look at example 6. It says we've got a coordinate A, which is 2, 3. So remember, that means that you go across 2. The first one is always x. You go across 2 and then up 3 for the y. And another coordinate, which is B, which is 6, 11. So again, that means we go across 6 on the x and then up 11 on the y. And it's asking us to find the midpoint of AB. So again, if we plotted those on a graph, 2, 3 would be about here, 6, 11 maybe up here, so that would be A, that would be B. AB would be a line, and we need to find where's the middle of this. But as you can see, we don't have a graph, and we don't want to waste time drawing a graph, because there is a way to do it mathematically without a graph. So if we just go back, and we'll just look at the example that we did with the graph to find out how it works, and then we can go ahead and use that knowledge on example 6. What we can say is the middle is what we call the average. It's the average of this point and this point. And you should know from basic stats understanding, the average of something, if you wanted to find the number between 5 and 8, you could simply do 5 plus 8 and then half it. So 5 add 8 would be 13. Half of 13 is 6.5. So the number that falls bang in the middle of 5 and 8 on a number line would be 6.5. That would be smack bang in the middle. And how we found that is by basic stats understanding, where you simply, if you need to find the mid value of anything, given two values, you add it together and you divide by 2. So we can check to see if our midpoint will work using that understanding. Let's check the x-coordinate. We already know the x-coordinate of this midpoint is -1. So let's add together the two x-coordinates and then half them. The first x-coordinate is here, 1. Okay, this x-coordinate for A is 1. The x-coordinate for B is -3. So that would be 1 plus -3 divided by 2. Well, 1 add -3 would be simply 1 take away 3, because a plus and a minus together just makes a minus. So 1 minus 3 would give us minus 2. And minus 2 divided by 2, how many 2's go into minus 2? 1, and a minus and a positive makes a negative. So we have in fact proved, using some basic maths statistics and finding the average by adding them together and divided by 2, that the x-coordinate is in fact 1. But when we had the graph, it was easier just to look and see that it was minus 1. I meant minus 1, not 1. So we can take that understanding into this example here. And we can say, right, if we need to find the midpoint of these 2 points A and B, we can simply take the x values and add them together, and then half it, and then take the y values, add them together, and then half it. So if we focus on the x coordinate is going to equal both of my x coordinates added together, so 2 plus 6, and then we're going to half it. So 2 plus 6 is, I'll just put some colours on there so you can see where I've got it from. 2 plus 6 is 8. 8 divided by 2 is 4. So that means the x-coordinate of our midpoint is 4. To find the y-coordinate of our midpoint, we simply need to do the same, but for the y-coordinates, we've got 3 and 11. So we'll do 11 and 3 added together, and then half it to find the middle of those 2 points. 3 add 11 is simply going to be 14. 14 divided by 2 is 7. Okay. So that means that the midpoint coordinate, when we write it as a coordinate, because it wants the actual coordinate, not just the numbers, and a coordinate is in a bracket, and MP means midpoint, remember? It's a lazy way, mathematical way to write midpoint without having to write it out full. The midpoint, well, the x is 4, so I can say it's 4. The y is 7, 7. And that will be that question complete. So the x is 4 and the y is 7. Okay. So we could prove that. We could go and look at proving that. We could even get up a graphing calculator to prove that, which if you want to, you can. Or what you could do is sketch that. You could actually draw those 2 points on a graph, sorry, and then work out where the line's going to be, draw the line, and then you could actually manually look at it visually and see that the midpoint would in fact be 4, 7. Okay, so that brings us now on to drawing lines. So the second part of this lesson will be, how do we draw basic straight lines? So we need to look at how do we draw x equals and y equals lines. Okay, so example 1. It says draw the line x equals 1. Draw the line x equals 1. So, how do we go about that? Well, we need to use our coordinate understanding to introduce this, and once you've sort of seen it, you'll realise that it's very straightforward and you don't have to do the long method every time. You'll just know how to plot them. But this says that x equals 1, so that means this line will have x equals 1 for every single point. So what would that look like? Well, that means for every y value, x is always 1. So when y is 0, x is 1. When y is 1, x is 1. When y is 2, x is 2. So if we drew a basic coordinate table where we've got x and y, we know that if y was 0, x will always be 1. Tells us x is 1. It means when y is 1, x will be 1. When y is 2, x will be 1. When y is 3, x will be 1. It's telling us that x will always be 1. So if we plotted these coordinates here, we could say these are coordinates, aren't they? X, y, remember, x, y. X, y, we could say that these are coordinates, okay? If we plotted these, 1, 0, so across 1, up 0, that'd be there. If we plotted 1, 1, across 1, up 1, that'd be there. If we plotted 1, 2, across 1, up 2. Across 1, up 2. 1, 3, across 1, up 3. And as you can see, this is just creating a straight line that goes directly through the x-axis at 1. So if I connect all of those points together with a nice straight line, hopefully you can see that, and if I get it through the points, hopefully you can see that this line x equals 1 is simply a line that goes directly through the x-axis at 1. It's telling us that for any point of y, whatever y is, x will always be 1, which essentially means it is a straight line. So x equals 1 would be the blue line that I've just drew there. It is a straight line that goes directly through the x-axis at 1. Okay, so let's have a look at some more examples and see if we can sort of see a pattern without having to consistently draw this. Okay, sorry about that. I've just had to reset the screen recorder. Hopefully that's back in action now. Example 2. Example 2 says, draw the lines x equals 2, x equals minus 3, and x equals 0. Now, we've just seen that the line x equals 1 goes directly through the x-axis at 1. So, using that logic, x equals 2 must be a line that has an x value of 2 for every y value, which means it must be a line that goes directly through the x-axis when x is 2. So that will simply be a line that goes straight through x equals 2. And it's as easy as that. Once you understand what x equals 2, x equals 1, x equals 3 means, they're very, very easy to draw. X equals minus 3. Well, what does that mean? X equals minus 3 means that for any y value, x will always be minus 3. So for any of these y values here, x will always be minus 3. So you'll simply have a point at minus 3 for every y point. Or essentially, you can just think of this as a line that goes through the x-axis at minus 3. So the line x equals minus 3 would be the one that goes through the x-axis at minus 3. And you might be thinking this is very straightforward, and it is. But I'm going to tell you a mistake that a lot of students make after we have done x equals 0. So x equals 0. X equals 0 will be a line that goes through the x-axis at 0. So through the x-axis at 0. And what you can see is this will be a line that actually maps on top of the y-axis. So the line x equals 0 again, for every y value, x would be 0, so it would be 0, 0, 0, 0 for all y values. So you can see it's a line that goes through the x-axis at 0. Well, that is just the y-axis. So we could even call x equals 0, or we could just call it the y-axis, because it's the same thing. So another word for the y-axis is x equals 0. It's the line x equals 0. Now, let's talk about the mistakes that students make. So you might be thinking this is very straightforward, and it is. But the trap and mistake that students fall into is, if you think about the x-axis, if you think about x, you would naturally think across. X is across, isn't it? So what you find is students draw their lines the wrong way. They draw their lines across. So instead of putting x equals 2 as a line that goes through the x-axis at 2, they draw a line going across at 2. Here, they draw this line. They find 2 and they think, oh, the x-axis goes across. And they think that is x equals 2. Because it's the same line as x. They think because the x-axis is horizontal, x equals 2 will also be horizontal, but that is not how it works. That would be completely wrong. X equals 2 means that it goes through the x-axis at 2. X equals 0 is through the x-axis at 0, and x equals minus 3 would be through the x-axis at minus 3. Or all of those x points at any y value would be minus 3 or 0 or 2 in that case for those lines. So very straightforward. Just remember x is going down. Yeah, it goes through the x-axis, not parallel. It's not parallel, it is through. Okay, so that takes us on to example 3, where I have drawn 3 lines, A, B, and C, and I want you to tell me the equations of them. So equations look like this. Given these lines and the understanding that we just discussed, what would the equation of A, B, and C be? Well, let's start with A. A equals, well, A. What is the equation of A? Well, first of all, A is a line that goes straight through the x-axis. So that means I know it's going to be x equals, okay? Because it's going through the x-axis, it will be x equals. Where does it go through the x-axis? Well, it goes through the x-axis at 2. So this is the line x equals 2. Part B, or line B. Maybe I'll do that in green. Line B. Again, looking at this, I can see it as a straight line that goes through the x-axis at minus 1. So if it's going through the x-axis, it must be x equals minus 1. Line C. Hopefully you might have already done it before me. Line C. Again, is a line that is going through, straight through the x-axis, so it must be x equals. Where does it go through the x-axis? At the point minus 4, so this would be x equals minus 4. Okay, and it's as simple as that. Moving on to example 4. Now I've asked you to draw the line y equals 1. So we're off of the x equations now, and we're moving on to look at the y equation. So y equals 1. And hopefully you might be sort of seeing a pattern here and thinking, well, if x equals 1 is a line that goes through the x-axis at 1, y equals 1 must be a line that goes through the y-axis at 1. And if you're thinking that, you'd be right. But just again to prove why this is the case, if y equals 1 and we draw a xy table, x coordinate, y coordinate, this is saying that for any x value, so if x was 0, y would be 1. because it says y equals 1. If x was 2, y would be 1. If x was 3, y would be 1. If x was 4, y would be 1. Y would always be 1 for whatever x is. And if we turn that into a coordinate, we can see that if we start to plot these coordinates that I've made here, 0, 1, start at the center always, go across 0, so stay where I am, and up 1. Okay, so that would be there, if I mark that point on. 2, 1 would mean start at 0, go across 2, up 1, and that would be that point there. 3, 1, go across 3, up 1, that would be that point there. 4, 1, across 4, up 1, that would be that point there. If I draw a straight line that goes through those points and connects them, you'll see that the point, or the line, y equals 1, is simply, as discussed a second ago, a line that goes directly through the y-axis at 1. Simply, straight through the y-axis at 1, because for every value of x, y will always equal 1. Okay, so you don't have to draw this table. I'm just illustrating how it works, the understanding of it. Once you understand it, you can draw these lines very quickly. But again, be careful. As you can see here, the y-axis goes up and down, but the line y equals 1 goes across. That is because it is a line that goes through y is 1 and every value of y is equal to 1. The mistake students make is, because the y-axis goes up and down vertically, they like to draw y equals 1, they put it here, where my red line is now. But we know, don't we, that that is actually x equals 1. So that is wrong. And I can see why students do it, because it makes sense, and almost there's some logic behind it, that the y-axis is up and down, so they think y equals 1 would be also vertical up and down. But it's not. It's a line that goes through the y-axis at 1. So from that understanding, you should be able to easily plot example 5, y equals 3. Well, y equals 3, what does that mean? That means a line that goes through the y-axis at 3. Well, the y-axis at 3 is here, and it needs to go through it. So it's a line that goes directly through the y-axis at 3. So our line y equals 3 would be the blue one. Y equals minus 2. What does the line y equals minus 2 look like? Well, again, it is a line that goes through the y-axis at 2, the minus 2. The minus 2 is on the y-axis here, and I just need a line that goes directly through that. So this would be y equals minus 2. And hopefully you're starting to see a pattern, and maybe even done it yourself, which is brilliant. And then finally, y equals 0. Well, what does that mean? That means a line that goes through the y-axis at 0. So through the y-axis at 0, what does that look like? Well, here's the y-axis, where's 0? Here. So through that, and again, this in fact is just the x-axis. This line here that I'm drawing in green is y equals 0. It is where the straight line goes through the y-axis at 0. But we also know that that line is called the x-axis. This is called, or another word for it is the x-axis. So if you ever see y equals 0, you should think, oh, that's just the x-axis. Really, really useful to know that. Okay, so that takes us on to our final two examples. We're now going to see if we can say what these lines are called, given them drawn for us. Okay, so I have drawn A, B, and C here for you, and I want you to tell us, or tell me, What are these lines? What are the equations of these lines? Well, if we start with A, we should look at A. What is A doing? A is going through the y-axis at 5. So if it's going through the y-axis, that means it must be y equals 5. If it is, in B's case, going through the y-axis at the point 1, it must be y equals 1. And for part C, if this line is, if we look at the line and think to ourselves, what's happening? It's going through the y-axis at -3, which means it must be, all the values for y is -3. Yeah, no matter which x point you choose, y is always -3, always. So it must be y equals -3. Okay, and it is as simple as that. Whichever axis the line is going through is the equation. If it goes through the y-axis, it is y equals. If it goes through the x-axis, it is x equals. Okay, so this takes us on to example 7. And this is where we will finish. And then I've got plenty of questions for you to practice after this. Draw the lines x equals -3, x equals 1, y equals 2, and y equals -4. So hopefully at this point you could even maybe pause the video, have a go at it yourself. But if we start with the first equation, x equals -3, what do we know about that? We know that that is a line that goes through the x-axis at -3. So where is the x-axis? It's here. Where's -3? Here. We need a line that goes through that. So we're going to draw a line that goes directly through that -3 on the x-axis. So that is our line, x equals -3. And a really good tip, whenever you draw lines, label them. Yeah? Label them so you know which one's which. So I've just drawn x equals -3, so I'm going to label it x equals -3. X equals 1. What does that mean? Again, it's a straight line that goes through the x-axis at 1. So it's going to be a line that comes down through here. Okay, so that is a line that goes through the x-axis at 1. And label it. Always label your lines once you've drawn it. X equals 1. And I'm just going to colour coordinate it for you, so it's easy for you to see. Next line, y equals 2. The line y equals 2, what does that mean? That means a line that goes through the y-axis at 2. So where's the y-axis? Remember, it's the vertical y-axis. You can see it labelled as y. And we need a line that goes through that at 2. So we're going to draw a straight line that goes directly through y equals 2. Make sure it's straight. Okay, and we're going to label that y equals 2, just so it's clear in our workings. And I'll just highlight it the same colour as the question. Okay, so we've got one more line to draw, y equals -4. What does that mean? That is a line that goes through the y-axis at -4. Okay, so we need a line that goes through the y-axis at -4. So -4 is down here, and it's going to go through that y-axis there. So that is the line y equals -4. Okay, so we've done that. That has been done. We have drawn all 4 lines that it's asked us to draw. And now we can answer the question. It says, write down the coordinates that make the rectangle. Well, hopefully you can see that our 4 lines that we've drawn has made a rectangle in the center. Okay, so if I just highlight this rectangle inside, hopefully you can see we have made a rectangle. contained by our 4 lines. Okay, we've made that rectangle there. We need to write down the coordinates that make this rectangle. What does that mean? Well, what makes this rectangle? Which coordinates? It's going to be the corners. It's going to be this point, this point, this point, and this point. So these 4 corners, the vertices of this rectangle, is what makes the rectangle. So we need to write the coordinates of each of these points. So this now ties us all the way back to the beginning of this lesson. The best thing we could do here is label our points. So I'm going to label the first one A, the second one B, the bottom one C, and the last one D. That means that we can talk about them. We can say that A is a coordinate, B is a coordinate, C is a coordinate, and D is a coordinate. So what you now need to do is look at your nicely drawn graph, look at our nice rectangle, and ask ourselves, right, what is this coordinate for A? How do I get to A? If I start at the center always, I've got to go across to -3 and then up to 2. So across comes first, remember the coordinate is x, y. So I'm going to go across -3 and up 2. How do I get to B? Starting from the origin, the center, I'm going to go across 1 and up 2. Across 1 and up 2. So the coordinate would be 1, 2 for B. How do I get to C? C, starting at the center, I've got to go across, always across first, x is always first. I've got to go across 1, and then on the y, I've got to go down to -4, so -4. 1, -4. D, how do I get to D? Starting at the origin, I go across to -3, so the x is -3, and then down to -4, so the y is simply -4. So the coordinates that make up our rectangle are -3, 2, which is A, 1, 2, which is B, C -4, which is C, and -3, 4, -4, which is D. And if you tie that back in, you can see that they are in the quadrants that we spoke about with the positive and negatives. Okay, so what we're going to do is now you have the opportunity to look at coordinate and basic line practice. So everything that we've just gone through, you can practice now. So if you can please have a go at those. The solutions are in the description of the video. Hopefully you managed to learn something. Thank you for joining in. If you've got any questions, just post a comment or send me a message on Facebook, and I'll see you in the next one.